It's a frigid morning in March 1944, and Oberleutnant Klaus Werner stands in a bombed-out hangar outside Berlin, staring at something that shouldn't exist. The drop tank sits on a wooden workbench, dented and scorched, its aluminum skin still reeking of high-octane fuel. Werner runs his gloved hand along the seam where American engineers welded two halves together. Outside, air raid sirens wail in the distance, another wave of bombers, probably already over the Danish coast. His superior officer, Hauptmann Friedrich Eber, leans against the doorframe, smoking. "Tell me again where they found this?" "Pulled from a wreck near Magdeburg," Werner says, not looking up. "P-51 Mustang. Pilot didn't make it." Eber exhales smoke through his nostrils. "And?" Werner taps the tank with his knuckle. It rings hollow. "This is what I've been telling you about. This is how they're doing it." "Doing what? Reaching us?" Werner finally meets his eyes. All of us. Every factory. Every airfield. Every city from here to Munich. Eber drops his cigarette, crushing it under his boot. He walks to the workbench, studying the tank like it's a bomb that might still detonate. Because in a way, it is. How much fuel does it hold? Roughly 108 gallons. But that's not the point. Werner pulls out a crumpled map, spreading it across the tank's surface. The point is what it means. If they can carry this much extra fuel, if their escorts can stay with the bombers all the way to Berlin and back, he traces a finger from England to the heart of Germany, then nowhere is safe anymore. The two men stand in silence, the implications settling over them like ash. The war just changed. They're only now beginning to understand how. To understand why this drop tank mattered, we need to rewind to 1943, when the Allied bombing campaign over Europe was bleeding to death. The American strategy was straightforward, almost brutally simple. Daylight, precision, bombing. While the British RAF pounded German cities by night, turning Dresden and Hamburg into firestorms, the Americans believed they could surgically strike factories, oil refineries, and rail yards during the day, destroy Germany's ability to make war, and you win. There was just one catastrophic problem. The bombers, those legendary B-17 Flying Fortresses and B-24 Liberators, couldn't reach their targets and survive. Not without fighter escorts. And the escorts couldn't fly deep enough into German territory before running out of fuel. Think about the math for a moment. A B-17 cruises at about 170 miles per hour at 25,000 feet, fully loaded with bombs and fuel. From bases in England to Berlin, roughly 600 miles. That's a 1,200-mile round trip, plus combat maneuvering, plus the fuel you burn climbing to altitude, plus a reserve for emergencies. The early American escort fighters, P-47 Thunderbolts and P-38 Lightnings, could manage maybe 300 to 400 miles of escort radius. They'd shepherd the bombers to the German border, then waggle their wings in a heartbreaking farewell and turn back, fuel gauges dropping into the red. And that's when the Luftwaffe would strike. On October 14th, 1943, the 8th Air Force launched Mission 115, a raid on the ball-bearing factories in Schweinfurt, deep in southern Germany. Without fighter cover for most of the route, German interceptors tore into the bomber formations like wolves into sheep. Of the 291 B-17s that took off that morning, 60 didn't come home. 60. That's a loss rate of over 20%. Another 138 bombers returned with damage. Shredded wings, dead engines, Wounded or dead crew members slumped in their positions. The 8th Air Force called it Black Thursday. Bomber crews called it a death sentence. General Henry Hap Arnold, commanding the Army Air Forces, faced a brutal reality. If losses continued at this rate, the entire daylight bombing campaign would collapse within months. Crews would refuse to fly. Replacements couldn't be trained fast enough. The strategy that was supposed to bring Germany to its knees was instead breaking the backs of American air power. The Allies needed a fighter that could go the distance, a fighter that could escort bombers to Berlin, engage the Luftwaffe over the target, and still have enough fuel to make it home. They needed the impossible. The P-51 Mustang wasn't supposed to save the war. In fact, when it first flew in 1940, designed by North American Aviation for the British, it was something of a disappointment. Fast? Absolutely. Beautiful? Gorgeous. All sleek lines and aggressive stance. But at altitude, where the real war was being fought, the original Mustang with its Allison engine was mediocre at best. Then someone had an idea that bordered on genius. What if you took the Mustang's exceptional airframe, that low-drag design, those laminar flow wings, and married it to Britain's Rolls-Royce Merlin engine? The same engine that powered Spitfires to victory in the Battle of Britain. Packard, the American luxury car manufacturer, was already building Merlin engines under license. In late 1942, the first P-51B Mustangs rolled off the production line with Packard Merlin engines. And suddenly, the Army Air Forces had a fighter that could do 440 miles per hour at 30,000 feet, dance with anything the Luftwaffe could throw at it, and, most importantly, had room for fuel. Lots of fuel. The Mustang's internal fuel capacity was good, 184 gallons in various tanks throughout the fuselage and wings. That gave it a range of about 400 miles on internal fuel alone, which was respectable. But it wasn't enough. Not for Berlin. That's where the drop tank entered the picture. External drop tanks, or external fuel tanks in official parlance, weren't new technology. They'd been used since the 1930s. The concept is simple. Hang extra fuel tanks on hardpoints under the wings or fuselage, feed from them first, and when they're empty or you need to fight, punch a release button and let them fall away. Instant weight reduction, full maneuverability restored. The devil, as always, was in the details. Early drop tanks were problematic. They were heavy even when empty. They created drag, reducing speed and range. The fuel feed systems were unreliable. Tanks would fail to transfer fuel properly, or pumps would malfunction at altitude, and they were expensive to manufacture, requiring tooling and materials that were in short supply. But by late 1943, American engineers had refined the design. They developed pressed steel drop tanks that could be mass-produced in automobile factories. They improved the fuel transfer systems, adding pressurization to ensure reliable flow at high altitude. And they experimented with different sizes, 75-gallon tanks, 108-gallon tanks, even massive 150-gallon tanks for the longest missions. The math suddenly became beautiful. A P-51B with full internal tanks, 184 gallons, plus two 108-gallon drop tanks carried 400 gallons total. At cruise settings, the Merlin engine burned about 60 gallons per hour. That's nearly 7 hours of flight time. 7 hours. Do you understand what that meant? That meant a Mustang could take off from England, climb to altitude, fly 650 miles into Germany, fight for 20 minutes over Berlin, and still have enough fuel to make it home. For the first time in the war, American fighters could go anywhere the bombers could go. In December 1943, the first long-range P-51 escorts began arriving in England. In January 1944, they flew their first missions deep into German airspace. And in March 1944, they reached Berlin. The date is March 4th, 1944. It's a cold, clear morning at airfields across eastern England. Mechanics scramble over P-51s, topping off internal tanks and hoisting drop tanks into place beneath the wings. Pilots attend briefings in crowded rooms, thick with cigarette smoke, studying maps and memorizing landmarks. The target? Berlin, the capital of the Third Reich, the beating heart of Nazi Germany. It's a psychological blow as much as a military one. Hitler himself had boasted that no enemy bomber would ever reach Berlin. The Luftwaffe chief, Hermann Göring, had famously declared, "If an enemy bomber reaches the Ruhr, my name is not Göring. You can call me Meyer." Well, the Allies had been pounding the Ruhr for 2 years, and today they were coming for Berlin. Colonel Don Blakesley, commanding the 4th Fighter Group, briefs his pilots. "Gentlemen, our job is simple. We stay with the bombers. We don't go hunting for kills. We don't break formation to chase stragglers. We protect the heavies all the way there and all the way back." Questions? A young pilot raises his hand. "Sir, what if we run into trouble?" Blakesley's expression doesn't change. "Then you deal with it. But you deal with it while staying with the bombers. Clear?" "Clear, sir." At 10 a.m., the first Mustangs lift off, drop tanks heavy under their wings. They form up in the cold English sky, joining the massive bomber formations. Hundreds of B-17 and B-24s, silver crosses against the clouds, already droning toward the Channel. The Armada crosses into German airspace. Below, the landscape unfolds, neat fields, villages, rivers snaking through valleys. And then, as they penetrate deeper, the bombed cities, the cratered rail yards, the skeletal remains of factories. The Luftwaffe rises to meet them. German fighters, Focke-Wulf 190s, Messerschmitt 109s, tear through the formations. Contrails streak across the sky. Tracers arc through the thin air. Radio chatter erupts. "Bandits, 2 o'clock high! I'm on him. Watch your 6. But this time the American fighters don't turn back. This time they stay. Lieutenant Urban Ben Drew, flying with the 361 Fighter Group, spots a German Me-262 jet fighter, one of Germany's newest weapons, streaking through the bomber formation. He banks hard, drop tanks still attached, and gives chase. The jet is faster, but Drew anticipates its moves, leading it perfectly. A burst from his 6.50 caliber machine guns, and the jet trails smoke, spiraling downward. First jet kill of the war for the 8th Air Force. The bombers reach Berlin. The city sprawls below, enormous and industrial, smoke already rising from earlier fires. Bomb bay doors open, thousands of bombs tumble into the thin air, whistling downward. And then the long flight home begins. Fuel gauges drop. Some Mustangs, damaged in combat or having burned too much fuel in hard manoeuvring, don't make it. Pilots bail out over German territory or ditch in the North Sea, hoping for rescue. But most make it back. They land as the sun sets, mechanics rushing to count holes, pilots climbing down on shaky legs, the adrenaline finally wearing off. They'd done it. They'd reached Berlin and returned. And the German High Command, monitoring the raid from bunkers and command posts, realized with cold certainty that the war in the air had fundamentally changed. This brings us back to that hangar outside Berlin, where Oberleutnant Klaus Werner and his team are dissecting the P-51's drop tanks. The Luftwaffe's technical intelligence units were some of the best in the world. Throughout the war, they'd recovered crashed Allied aircraft, studying every detail: engines, avionics, weapons, armor. They'd shipped entire wrecks back to test facilities, where German engineers would rebuild them, fly them, understand their strengths and weaknesses. But the drop tanks were different. The drop tanks represented something more fundamental than incremental improvement. They represented strategic reach. Werner's report, filed in mid-March 1944, makes for chilling reading. Translated from the German, it states, "The enemy has solved the fundamental problem of long-range fighter escort through the use of large-capacity external fuel tanks. The recovered tank shows evidence of pressurized fuel transfer systems, allowing reliable operation at altitudes exceeding 7,000 meters. Construction is simple, using stamped steel panels, suggesting mass production capability. Weight, when empty, is approximately 20 kilograms per tank. Based on analysis of the P-51B's known internal fuel capacity and performance characteristics, we calculate that with 2 such tanks, the Mustang can escort bomber formations to any target within the Reich and return to bases in England. This fundamentally alters the strategic bombing campaign's viability. Previous defensive strategies predicated on Allied fighters turning back at the border are now obsolete. New tactics must be developed immediately. The report goes up the chain of command. It reaches Göring's desk. It reaches Hitler's inner circle. And they all realize the same thing. It's too late. Germany's aircraft production, while still impressive, is being stretched thin across multiple fronts. The Luftwaffe is bleeding experienced pilots faster than it can train replacements. Fuel shortages are becoming critical as Allied bombers destroy synthetic fuel plants. And now, with American fighters able to penetrate to any target in Germany, the defensive advantage that had made daylight bombing so costly has evaporated. Major Heinz Knoke, a decorated Luftwaffe fighter ace, writes in his diary in April 1944, "Today, we intercepted bombers near Hanover. The American Mustangs were everywhere. We barely engaged before being forced to break off. The sky belongs to them now." Another pilot, Hans Philipp, an ace with over 200 kills, is shot down and killed by a Mustang on October 8, 1944, during a mission where he was hopelessly outnumbered. The Luftwaffe's fighter arm, once the pride of the Third Reich, is being systematically destroyed. Here's what's remarkable about the drop tank story. It's not about a single dramatic breakthrough. It's about how a relatively simple piece of technology, extra fuel capacity, created a cascade of strategic effects that accelerated Germany's defeat. Let's trace the chain reaction. Effect 1. Bomber losses plummet. With fighter escort all the way to the target and back, bomber losses drop dramatically. In the first quarter of 1944, before long-range escort became routine, bomber loss rates averaged 3 to 5% per mission. By summer 1944, with Mustangs providing continuous protection, that drops to 1 to 2%. It doesn't sound like much, but it's the difference between a sustainable campaign and a death spiral. Bomber crews' morale improves. They know they're not alone over Germany. They can see the Mustang's silver wings above them, twisting and turning as they fend off German fighters. It's psychological as much as tactical. Effect 2. The Luftwaffe bleeds pilots. With American fighters now able to hunt anywhere in German airspace, Luftwaffe pilots can't avoid combat. They're forced to engage, often at a numerical disadvantage, often with less fuel and less experienced wingmen. German pilot training programs are shortened as the need for replacements becomes desperate. New pilots arrive at frontline squadrons with perhaps 50 hours of flight time, compared to 200 to 300 hours for their American counterparts. They survive, on average, about 5 missions. The Luftwaffe's kill-to-loss ratio, which had favoured them in 1943, reverses. By mid-1944, German fighters are being destroyed faster than factories can replace them. Effect 3. Oil and fuel plants become viable targets. This is perhaps the most devastating cascade effect. With long-range fighter cover, the Allies can now systematically target Germany's synthetic fuel production. Germany, lacking natural oil reserves, had built a sophisticated network of plants that converted coal into synthetic fuel. These plants were critical to the war effort, powering tanks, aircraft, trucks, submarines, everything. But they were also deep inside Germany, previously protected by distance and the Luftwaffe. Not anymore. In May 1944, the Allies launch Operation Point Blank, specifically targeting oil production. Mustang-escorted bombers hit Leuna, Pölitz, Merseburg, Brooks, the major synthetic fuel complexes. The attacks are devastating. By September 1944, German aviation fuel production has dropped by 90%. Fighter units receive fuel allocations barely sufficient for short flights. Training is all but suspended. Pilots learn to glide their fighters into landings to save every drop of fuel. Tanks sit immobilized in France for lack of fuel. U-boats remain in port. Entire Wehrmacht divisions are paralyzed. All because the Allies can now strike anywhere, anytime, with impunity. Effect 4. Psychological impact. There's a less tangible but equally important effect. The psychological impact on both German civilians and leadership. For years, Hitler had promised that Germany's borders were secure, that the Luftwaffe would protect the fatherland. Now, daily, thousands of American bombers and fighters roared overhead in broad daylight. Cities burned, factories exploded, and there was nothing anyone could do about it. Albert Speer, Hitler's armaments minister, later wrote, "The day we realized American fighters could reach Berlin was the day I knew we'd lost the war. Not because of one raid, but because of what it represented. We could no longer defend our own skies." Let me give you some statistics that hammer home just how much the drop tank changed the equation. January to March 1944, before widespread long-range escort. Total bomber sorties: 27,000 bombers lost, 816. Loss rate: 3.0% June to August 1944, with full long-range escort. Total bomber sorties: 63,000 bombers lost, 892. Loss rate: 1.4%. Same Luftwaffe, same German defences. But the loss rate cut by more than half, while sortie rates more than doubled. Or look at it from the German perspective. Luftwaffe fighter losses. January 1944, 1,311 aircraft. June 1944, 2,235 aircraft September 1944, 3,013 aircraft. By late 1944, the Luftwaffe was losing more fighters every month than its factories could produce. And fighter pilot casualties tell an even grimmer story. Luftwaffe fighter pilot casualties: killed, missing, or captured. 1943, full year, 2,870 pilots. First 6 months of 1944, 3,490 pilots. In just 6 months, Germany lost more fighter pilots than in the entire previous year. The math became inexorable. Germany simply couldn't sustain these losses. The Allies could. To be fair to the Luftwaffe, they didn't surrender the skies without a fight. German engineers and tacticians tried everything they could think of to counter the Mustang threat. Tactic 1, rocket-armed fighters. The Germans developed the WFR grade 21 rocket system, large 21-centimeter rockets mounted under the wings of fighters. The idea was to launch these from outside the range of bomber defensive guns, breaking up the formations before closing for conventional attacks. It sounded good on paper. In practice, the rockets were inaccurate, heavy, and created massive drag. And Mustang pilots quickly learned that a rocket-armed fighter was slow and vulnerable. Spot the telltale bulge under the wings, dive in before they can launch, and it's an easy kill. Tactic 2, heavily armed bomber destroyers. The Luftwaffe created specialized Sturmgruppen, assault groups equipped with heavily armored and armed Focke-Wulf 190s. These carried extra armor plate, heavier cannons, 30mm instead of 20mm, and were specifically trained to press home attacks on bombers, regardless of defensive fire. Again, good concept. The problem was the Mustangs, Sturmjäger pilots, committed to their bombing runs, fully armored and flying in tight formation, were sitting ducks for escorting fighters. The assault groups suffered catastrophic losses. Tactic 3, jet fighters. Germany's Me-262 jet fighter was a genuine technological leap, too fast for Allied piston-engine fighters to catch in level flight, heavily armed and beautiful in a predatory way. But it arrived too late, in too few numbers, and with too many problems. Jet engines were temperamental, requiring frequent overhauls. Pilot training for jets was minimal. And critically, the Me-262 was vulnerable during takeoff and landing, still accelerating or slowing down, unable to use its speed advantage. Allied pilots learned to patrol German jet airfields, waiting for 262s to take off or land. It became known as rat catching. Even with jets, Germany couldn't regain air superiority. Tactic 4, dispersion and decentralization. The most successful German response wasn't tactical, but strategic. They dispersed their industry. Aircraft factories were moved underground into old mines and caverns. Production was decentralized across hundreds of small workshops. It worked to an extent. Aircraft production actually increased in early 1944, despite the bombing. But it didn't matter. Without fuel, without trained pilots, and without control of the skies, more aircraft just meant more targets sitting on the ground. By December 1944, the Luftwaffe was a shell of its former self. The last great offensive, Operation Bodenplatte, a massed attack on Allied airfields on January 1st, 1945, saw the Luftwaffe commit over 900 aircraft. They destroyed about 450 Allied planes, mostly on the ground. But German losses were catastrophic: 271 aircraft and, more importantly, 214 pilots, many of them experienced formation and squadron leaders. The Luftwaffe could replace the planes. It couldn't replace the pilots. After Bodenplatte, organized Luftwaffe resistance essentially collapsed. Behind all these statistics and strategic analyses are individual human beings, pilots, gunners, engineers, living and dying in the frozen skies over Europe. Let me tell you about a few of them. Lieutenant Lee Buddy Archer. Buddy Archer was a Tuskegee Airman, one of the famed African-American pilots who flew P-51s with the 332nd Fighter Group. In October 1944, over Germany, Archer's wingman was hit by flak and bailed out. Archer, low on fuel, circled the parachute until German soldiers appeared, then made a strafing pass to keep them away from his friend until the pilot could evade and escape. Archer had only enough fuel for that one pass, and his drop tanks were long since jettisoned. He nursed his Mustang back to Allied lines, landing with his fuel gauge showing empty. His crew chief estimated he had about 2 minutes of fuel remaining when he touched down. The drop tanks got him to the fight. His skill and courage got him home. Hauptmann Heinz Baer. Heinz Baer was a German ace with 220 confirmed kills, one of the highest scoring pilots in the Luftwaffe. In April 1945, flying an Me-262 jet, he engaged a formation of P-51s over Bavaria. His diary entry from that day is poignant. The Americans were everywhere. For every one of us, there seemed to be 10 of them. I shot down 2 Mustangs, but there were always more. We are fighting ghosts now, endless streams of silver fighters that multiply like Hydra heads. I landed with battle damage and barely enough fuel to taxi to the hangar. We received notice that no fuel allocations will be available for 3 days. I may have flown my last combat mission. He survived the war. Most of his squadron didn't. Staff Sergeant Benjamin Warmer was a waist gunner on a B-17 named Southern Comfort. On his 17th mission, over Bremen in June 1944, his bomber was hit by flak and began trailing smoke. The pilot held formation long enough to drop their bombs, then turned for home. German fighters appeared, and so did American Mustangs. Warmer, manning his machine gun, watched the dogfights swirl around them. A Mustang passed so close he could see the pilot's face in the cockpit. "I knew we were going to make it," Warmer wrote later. "The fighters stayed with us all the way to the coast. When we finally saw England, I damn near cried. Those Mustangs saved my life." Southern Comfort made 87 missions total. The crew rotated home in August 1944. Step back from the individual stories and the specific battles, and you see something profound. The drop tank wasn't just a piece of military hardware. It was a demonstration of a fundamental principle of modern warfare. Strategic reach equals power. Whoever can strike anywhere, while protecting their own forces, controls the tempo and terms of conflict. The side that can only react, only defend, will eventually lose. Military historians often debate what won World War II. Was it Soviet manpower, American industrial production, British intelligence and code-breaking, the atomic bomb? All played roles, but the destruction of the Luftwaffe through the strategic bombing campaign, enabled by the simple expedient of giving fighters enough fuel to go the distance, was arguably the decisive factor in the European theatre. Without air superiority, Germany couldn't defend its oil production, couldn't protect its factories, couldn't support ground forces adequately. couldn't prevent the Allied build-up for D-Day. The invasion of Normandy succeeded in part because Allied air forces flew over 14,000 sorties on D-Day alone, compared to perhaps 100 sorties by the Luftwaffe. German reinforcements travelling by road or rail were spotted and destroyed. German armour couldn't move in daylight without being strafed. And all of that traces back, in a real sense, to those cylindrical metal tanks hanging under Mustang wings. The principle extends beyond World War II. Look at modern conflicts: Kosovo, Iraq, Afghanistan, Syria. Air superiority, the ability to strike anywhere while denying the enemy the same capability, is the foundation of contemporary American military doctrine. Aerial refueling has replaced drop tanks, but the concept is identical. Extend your reach, maintain your presence, control the battle space. The Pentagon's obsession with power projection, carriers, long-range bombers, global logistics networks, is the drop tank principle scaled to worldwide application. Before we wrap up, I want to spend a moment on the engineers and designers who made the drop tank system work. These weren't flashy heroes. They didn't fly combat missions, but their contributions were just as vital. The metallurgists, creating a fuel tank that could be mass-produced, that was light enough to not cripple performance, and that could withstand the stresses of high-speed flight and pressurized fuel transfer required sophisticated metallurgy. Engineers at North American Aviation and subcontractors experimented with different steel alloys, stamping techniques and welding processes. They developed tanks that could be manufactured in automotive plants by workers with minimal specialized training. The aerodynamicists, hanging two large cylinders under a fighter's wings, creates massive drag and alters the aircraft's handling characteristics. Aerodynamic engineers had to design mounting systems and fairing shapes that minimize these effects. They used wind tunnel testing, mathematical calculations done by hand, no computers in 1943, and incremental, real-world testing to optimize the designs. The fuel system specialists, getting fuel to reliably transfer from external tanks to internal tanks at 30,000 feet in sub-zero temperatures, while maneuvering in combat, is harder than it sounds. Early systems were plagued by frozen fuel lines, vapor locks, and pump failures. Engineers developed pressurization systems that used engine bleed air to maintain positive pressure in the tanks. They created valves that wouldn't freeze. They tested relentlessly until the system was robust enough for combat conditions. The logistics experts, finally, someone had to figure out how to manufacture, ship, store, and install hundreds of thousands of drop tanks across air bases in England, Italy, and eventually the Pacific. This involved coordinating factories, transportation networks, supply chains, and maintenance procedures. It sounds boring. It was crucial. By mid-1944, drop tanks were so plentiful that pilots would jettison them at the first sign of combat, knowing there'd be fresh tanks waiting when they landed. That abundance came from careful planning by people whose names we'll never know. War is often portrayed as a story of generals and battles. The reality is that wars are won by thousands of people, solving thousands of small technical problems. The drop tank is a perfect example. While we've focused on the European theatre, drop tanks played an equally critical role in the Pacific War, though under different circumstances. The Pacific presented unique challenges: vast ocean distances, limited air bases, and island-hopping campaigns where the next airfield might be hundreds of miles away. When P-51s began arriving in the Pacific in 1945, they brought with them the same drop tank systems perfected over Europe. But the missions were even more audacious. On April 7, 1945, the 7th Air Force launched a raid on the Japanese mainland from Iwo Jima, a distance of 650 miles each way. P-51s escorted B-29's Superfortress bombers all the way to Tokyo and back, a round trip of over 1,300 miles. Without drop tanks, it would have been impossible. With them, it became routine. Japanese defenders faced the same realization as the Germans had a year earlier. Nowhere was safe. American fighters could reach any target in the Japanese home islands. The strategic bombing campaign against Japan intensified, culminating in the firebombing of Tokyo and, eventually, the atomic bombings of Hiroshima and Nagasaki. Air superiority, enabled by long-range fighters with drop tanks, made it all possible. After the war ended, the lessons learned from drop tank development influenced decades of military aviation design. The USAF's Strategic Air Command built its entire doctrine around long-range power projection. B-36 bombers, then B-52S, supported by tanker aircraft for aerial refueling. The concept of extending range through external fuel has never gone away. Modern fighter jets, F-15S, F-16S, F-35s, routinely carry drop tanks, now called external fuel tanks, or wing tanks, for ferry flights and long-range missions. The technology is more sophisticated, but the principle is identical. Even civilian aviation borrowed from wartime innovations. Long-range commercial flights became viable partly because of fuel management techniques pioneered during World War II, and in a broader sense, the drop tank story influenced how military strategists think about reach, sustainment, and logistics. The side that can stay in the fight longer, that can operate at distances that surprise the enemy, gains enormous advantages. Let's engage in a brief thought experiment. What if the Allies had never solved the drop tank problem? Imagine daylight bombing continuing as it had in 1943, with unsustainable losses. Bomber Command might have been forced to shift entirely to nighttime area bombing, sacrificing precision. Or the strategic bombing campaign might have been scaled back or abandoned altogether. Without air superiority over Germany, would D-Day have succeeded? Possibly, but at far higher cost, and with less certain outcome. Without the destruction of Germany's oil production, the Wehrmacht might have remained more mobile, prolonging the war. And if the war in Europe dragged on into 1946 or beyond, the entire geopolitical landscape of the post-war world might be different. Soviet forces advanced further west as Germany weakened. A longer war might have meant different occupation zones, different spheres of influence, perhaps even a different Cold War dynamic. This is speculation, of course, but it illustrates how seemingly small technical innovations can have outsized strategic consequences. A simple metal cylinder hanging under a fighter's wing helped reshape the world. On March 6, 1944, Major Klaus Reinhardt stood in a Munich hangar, staring at an American drop tank, and realized his side had lost the war. Not because of courage or determination or will to victory, because of fuel capacity and range calculations and the inexorable mathematics of attrition. The P-51 Mustang gets most of the glory. It's a beautiful aircraft, sleek, fast, deadly. It belongs on posters and in museums. But But the real hero of this story is uglier. It's a disposable aluminum cylinder, mass-produced by the thousands, designed to be jettisoned and forgotten. It's proof that wars are won not by the most dramatic weapons, but by the most practical ones. Not by the technologies that make headlines, but by the technologies that solve boring logistical problems. The drop tank gave American fighters the one thing they needed most: range, and with range came everything else: air superiority, bomber protection, ground attack capability, strategic flexibility. The Germans had better tactics at the start. They had experienced pilots. They had the advantage of fighting on interior lines, close to their bases and repair facilities. Today, if you visit the National Museum of the United States Air Force in Dayton, Ohio, you'll find a beautifully restored P-51 Mustang hanging in the World War II gallery. It's polished to a mirror shine, every rivet perfect, propeller blades gleaming. Underneath the wings, they've mounted a pair of reproduction 108-gallon drop tanks. Most visitors walk right past them, drawn to the aircraft itself, but if you stop and look, really look, at those crude aluminum cylinders, you're looking at the weapon that won the air war over Europe. Not bad for what Klaus Reinhardt called crude but effective. Sometimes, crude and effective is exactly what you need. Thanks for watching. If you enjoyed this deep dive into World War II aviation history, make sure to like and subscribe. Next week we'll be looking at another overlooked technology that changed the war, but I won't spoil the surprise. Until then, remember, the most important innovations aren't always the most dramatic ones. Sometimes the answer is just better plumbing.